Hello. Okay, so I have a hard, or at least it says it's hard, a hard coding challenge from, I think it's like dailycodingchallenge.com or something like that. So this is coming from them, and apparently this was a challenge given by Uber during one of their interviews. So this is like a real world problem to like try and figure out. Okay, so the problem goes like this. Given an array of integers, return a new array such that each element at index I of the new array is the product of all numbers in the original array except the one at I. For example, if our input was 1, 2, 3, 4, 5, the expected output would be 120, 60, 40, 30, and 24. If our input was 3, 2, 1, we expect 2, 3, and 6. Follow up, what if you can't use division? Okay, so this is definitely an interesting concept here. And I think actually, maybe I'm like oversimplifying this. I don't want to also like, so the division thing I recognize as you get the product of everything and then you divide by each index and then you go, and then you're done. That would be a big O of n, so it wouldn't be too bad. So actually, let's try that first, and then we'll do the follow-up one. Follow-up question after that. Okay, so I'm going to call this function leave out products. Okay, you take an array and then you do the thing. And just to be sure, I want to take this example they gave us and test it, of course. So const array equals that thing, and we're calling it leave out products. So I will, I believe it outputs a new array. Yeah, so it is a technically new array. So console.log that thing with the array, and that should give us what we're looking for. So let me just like minimize this, come down here. So if I do my node, it's under challenges, and call it Uber hard, I should get nothing back. Undefined, yeah, I should get undefined back. Okay, cool. So let's go through this. Okay, so I can easily find the product, the all products, or just the full product by doing like a quick reduce. We have the previous, or the accumulator and the item, or I should say num, and then we do this, and we make sure we start with 1 as our accumulator because you're doing multiplication, and so you do accumulator times number, and then you should get the product that way. So just to return product, just to see what that looks like, this product will be like 120. Yeah, that makes sense. Okay, so what we want to do is we want to take our array and we want to do basically a mapping, so that'll produce a new array, and for each num in that, we can do product divided by that number. And I don't think I need to worry about float values, so let's check what that looks like. And sure enough, we get the exact same thing that we were looking for over here. So this is working, I think, as expected. So the next question is, what if you can't use division? So this was a big O of n. This is big O of n, and I think I'm going to count the map also big O of n because it goes by each product, or by each element. Well, I think what I'd have to do is I can either do a slice, or I could do a slice of the stuff that's around the number. That gets kind of messy. I could do an accumulate for each one. Yes, what does that look like? Let me do another. I want to like copy this basically. So I can't do this stuff, right? I have to do something like array dot. I want to do array dot map, and for each element, I want the way this works is there's a value. So this is num, the index, and the array itself. I'm gonna call it the array, or I'll just call it A. Okay. So the array itself is part of the argument within the map callback function. So you can access it, and what I'm going to do is I'm going to say I want to accumulate on it, right? I want to take a.reduce, and reduce takes the accumulator, then the n for num, I'm blanking on variable names, and the current index, which I'll call j. Okay, and then I'm going to give this a little bit more room here, and I'll make sure that I have 1 as my my accumulator, which is here. Yes, I think that's where it is. Okay, so what I do here is I say wherever, so if j equals I, return the accumulator by itself. Don't do anything with it. Else, return accumulator times n. I think that's what, and I think I return that whole thing. I think it's very nested, so it's definitely not the easiest to read, but it will, I think, work. So let's do this. Okay, no, it does not. Array has already been declared, which was in here. Yeah, okay, so this is more of my thing here. So I don't need to reassign that. That's all. That's not part of the function, though. Yeah, okay, that worked exactly like I thought it would. So basically what's happening here is I'm doing a mapping on each element. Even though I'm not really using this number, so it's like underscore, I don't really need to use it. And then I have the index, which is what's important, and the array itself, which is, again, fed as an argument. So even though you're mapping on the array is supplied as part of the argument, and that is what I'm using here, because for each element with position I will reduce, and using an accumulator, again, across the whole array, which is just called A here. At A. I guess technically I could do like array because it's the same thing, but just to I'm using the information that's being passed. Good practice, I think. And then I'm reducing it. I'm just making sure that the I and the j aren't the same. If they are, then I just don't do anything. I just keep passing the accumulator around. So this works again like I expected. So this was supposed to be a hard one. I feel like I'm doing something. Maybe I'm hacking it with JavaScript a little bit. So perhaps I should not use these methods. I think it's fair to use them though, because like map is like fairly straightforward. I could always just like create a new array. So I think let me try that actually. So we have an out array, and again I'm just doing this because like that felt a little too easy honestly. So I'm trying to like just give myself a bigger breadth in terms of like what I'm knowledgeable about and how would I implement it without these methods. They are convenience after all. So for const num, it doesn't really matter, right? Actually, I do want the element I to be part of it, so I do need the I. I is less than array. Array.length. Length spelled properly. I plus plus. Okay, so for each one of those, I go through the array itself. So I do another for loop. So this is a little less efficient. Yeah. So this is definitely not. I didn't talk about the complexity here. So this is definitely like big O of n squared, but you don't have to use division. So if that's a really important thing to avoid, there you go. This is just j array, and I can just like kind of ignore the accumulate here. So let total equal 1, because I am multiplying. So if j equals j, then I just continue, and else total, I do multiplication times array.j, and it's .j, right? It's not. It's not .i. It's .j, and I need to push the total at the end of that, and then I return out at the end of that. So let me just double check this works. Okay, that worked again the second time. Yeah, I mean, okay, so I think I'm done with this. I did it 3 different ways, and I think that they all are very valid. If you have to absolutely avoid division, then you have to suffer a little bit in terms of time complexity, but not too bad otherwise. So, yeah, I think that was pretty good, and I will see you next time. Bye.